Hello, Mr. Chu here with another video in my Trey Arithmetic curriculum. So I've already done an earlier video on the Pythagorean Theorem. I called it Part 1. I'm calling this one Part 1A. It is still an introduction type video. We will do other Pythagorean Theorem videos, but you need to be able to watch them all. In order to see them all, you're going to have to either subscribe to my YouTube channel at Mr.KeithyChew or follow me on TikTok at Mr. KeithyChew. Make sure you like this video, subscribe and follow, and then you'll see I'm also on Instagram, but I don't have as long of videos there. So in an earlier video today, when I first introduced this, I posted it. I was wearing my same Under Armour hat and hoodie. I always like to wear hats and hoodies when I'm doing the Trey Arithmetic videos. I wear a tie when I'm doing my algebra and geometry ones, my bare algebra and my bracket geometry videos. But I'm more casual when we're doing the arithmetic and pre-algebra ones. So we talked about the Pythagorean Theorem requires that we have a right triangle. And remember, it's a right triangle if I have this little mark here, which means that is a right angle, and the side opposite the hypotenuse. The two sides that create the right angle are called legs, and their variables are a and b, and the hypotenuse is always c. And then we have a squared plus b squared equals c squared, being the basic Pythagorean theorem that is used in pre-algebra, in some arithmetic, in algebra and geometry. It is a very important formula used in the real world. Carpenters use it all the time. So whenever I had my first video, my Part 1 video, we had two problems I asked you to work. And I'll work through these, and then it'll be about time for me to post this video. So in student practice problem A, we have this right triangle, and the two sides that make up the right angle are called legs, and their variables are a and b. And remember, this is the hypotenuse across, and the hypotenuse is always c. Always. Here is the Pythagorean Theorem, so let's write it down. Substitute and solve. So wherever there's an A, I put a parentheses, and I'm going to put a 3. Square that. Wherever there's a B, I'm going to put a parentheses, 4, square that. And then C is what I'm solving for, so I don't have to have the parentheses there. If I have them there, I can just take it out after I substitute it in. 3 squared means 3 times 3, which is 9. 4 squared is 4 times 4, which is 16. And that equals C squared. 9 plus 16 is 25. And that equals C squared. Now I explained in our first video, Part 1, that whenever you have a number squared on one side of the equation and then a number, to undo that, the inverse is the square root. So I'm going to take the square root of the c squared and the square root of the 25. So the square root of c squared would be what multiplied by itself gives me c squared, and that's c. And then what number multiplied by itself gives me 25? That is 5. So c equals 5. Whenever all three numbers are integers on the lengths in a right triangle, we have a special group of numbers that are called a Pythagorean triple. We'll talk more about that in a future video, but until then, most books and curriculum would say I have a 3, 4, 5 right triangle because it's a Pythagorean triple. So now we look at problem B. The two sides that make up the right angle are called legs, which are A and B, from my formula that we set up over here. And we know the side opposite the right angle is going to be C, and now I substitute. So wherever I have an A, I have an A. And I have to square that. The B inside parentheses, I put a 9. and square that. The c inside parentheses, I put a 41 and square that. So a squared plus 8 squared is 81 equals 41 squared. I don't know what 41 squared is, but I can take and multiply 41 times 41 using the traditional algorithm that most students are taught in elementary school. 1 times 1 is 1. 1 times 4 is 4. I put a 0 here to hold that place since I've already used that first one. 4 times 1 is 4. 4 times 4 is 16. And now I add down 1, 8, 6, 1. So the answer to 41 squared is 1,681. 1,681. Now this is a two-step equation. I have to solve this by undoing the plus 81. And I had an earlier, bare algebra video in this. And I will make sure that I have more in this arithmetic folder. I'm just building up all my content at this time. So the way you solve this two-step equation, instead of adding 81, I do the inverse, which is the opposite, which is subtracting 81 using the subtraction property of equality. You'll need to know how to do that when you get into the geometry so you can write an algebraic proof. If I subtract 81 from the left, I have to subtract 81 from the right. On the left, this cancels out, and I always would teach my pre-algebra students to do that. A squared plus 0 is a squared, and 1681 minus 81 is 1600. Just like we did right here, the inverse operation to get rid of the a squared and make it just a is square root the a squared. Square root of 1600. What do you multiply by itself to get a squared? A. What do you multiply by itself to get 1600? 40. So I can say that this equals 40. And now I have another Pythagorean triple since they are all integers. And that's the way they would say a 9, 40, 41 will always be a right triangle. So make sure you check out, subscribe to my YouTube channel, and then up here will be a link to this original Pythagorean Theorem, part 1, where we just introduced the concepts. And then if you're on TikTok, make sure you follow me. I need followers. And then down here on the bottom will be a playlist of Pythagorean Theorem and distance formula problems as I continue to build them. Thank you for watching. I am Mr. Chu in my Under Armour hat and hoodie, and I want to help you become a better math student. I'll see you next time in Trey Arithmetic.